Hi, this is your Professor Sudha Kolathuparambil, Section 9.5 Hypothesis Test for a Standard Deviation. This section has two objectives: find the critical values of the chi-square distribution and test the hypothesis about the standard deviation of a normal distribution. The chi-square distribution was introduced in Section 8.4. The critical value chi-square alpha represents the value that has an area alpha to its right. And this is a Greek letter chi, and we pronounce this as chi. Objective 1. Find the critical values of the chi-square distribution. Hypothesis tests for a standard deviation are based on the chi-square distribution and denoted by like this. Chi-square distributions are skewed to right, and the values of chi-square statistic are always greater than or equal 0. There are actually many different chi-square distributions, each with different number of degrees of freedom. The figure below shows the several examples of chi-square distribution at different degrees of freedom. All these are skewed to right. The notation chi-square alpha represents the value that has an area alpha to its right. And we use table A4 to find the critical values associated with the chi-square distribution. Objective 1 is find the critical value of a chi-square distribution. So find the critical value of chi-square. Alpha is 0.05 and degrees of freedom 10. We consult table A4. The critical value is located at the intersection of the row corresponding to 10 degrees of freedom and the column corresponding to alpha equal 0.05. Objective 2. Test hypothesis about the standard deviation of a normal distribution. Test statistic for the hypothesis test is given here with chi-square distribution with n-1 degrees of freedom. This method will apply only for the samples drawn from a normal distribution. If the distribution differs even slightly from the normal, we cannot use this method. And we will focus on how to perform a test using the critical value method and table A4. This is the step-by-step procedure for hypothesis test for a standard deviation. First, check for the assumptions. We must have a simple random sample from a normal population. First, state the null and alternate hypothesis. Choose the significant level and find the critical value using table A4 and n-1 degrees of freedom. And find the critical value and decide whether it is a left tail, right tail or two tail depending on the alternate hypothesis. Compute the test statistic. Then compare the test statistic with the critical value and decide whether to reject the null hypothesis based on this condition. Then state a conclusion. Example on hypothesis test for a standard deviation. To check the reliability of a scale in a butcher shop, a test weight known to weigh 400 grams was weighed 16 times. For a scale to be considered reliable, the standard deviation of the repeated measurements must be less than 1 gram. The standard deviation of 16 measured weights was 0.8 grams. Assume that the measured weights are independent and follow a normal distribution. Can we conclude that the population standard deviation of measurement is less than 1 gram? Use alpha equal 0.05 as significance level. First, check for assumption. We have a random sample from a normal population, so the assumptions are satisfied. Now state the null and alternate hypothesis. We are interested in determining whether the standard deviation is less than 1 gram. That means alternate hypothesis will be sigma less than 1. So the null hypothesis will be sigma equal 1. Now step 2, choose the significant level. So it is given in the question. And find the critical value. Here they weighed 16 times, so n is 16. Number of degrees of freedom is n-1, so 16 minus 1 equal 15. We need to find the critical value. The degrees of freedom is 15 and it's a left tail test. Critical value is chi-square 1 minus alpha. So chi-square 1 minus 0.05, that is chi-square 0.095. So in the table A4, look at the number of degrees of freedom 15. Look at the row and the column corresponding to alpha equal 0.95. So that is the critical value. Critical value is 7.261. Step 3. Compute the test statistic. Use this formula to calculate the test statistic. In step 4, compare the test statistic and the critical value to determine whether to reject the null hypothesis. We reject the null hypothesis if the test statistic is less than the critical value, but here the test statistic is greater than the critical value. We do not reject the null hypothesis. Step 5. State a conclusion. There is not enough evidence to conclude that the population standard deviation sigma is less than 1 gram. We cannot consider the scale to be reliable. In this section, you learn how to find the critical values for a chi-square distribution and the assumptions for performing the hypothesis test for a standard deviation of a normal distribution. The assumption is we must have a simple random sample from a normal population. Also, you learn how to perform a hypothesis test for a standard deviation using the critical value method and table A4. You learned how to perform the hypothesis test for population mean, population proportion and population standard deviation. In next section, you will learn how to determine which method to use when performing a hypothesis test.